All right, let's have the most friction-free TCAD experience we can have. Um, Set up your VPN, remotely log into the machine, and start a terminal. Then just start a C shell, CSH, and then source the environmental variables. So /apps apps /t CAD underscore n dot csh, and we're on our way, right? So we're going to use the graphical interface Centaurus Workbench, SWB ampersand gives us back the shell. All right, and it wants a Centaurus Workbench database directory, which you can make up your own. Like I have things called TCAD and EE21. I'm going to use EE221 because that's what we did already, but I have things like you can make up whatever you want. You would just put a slash and type in the name, but I'm going to click this one. All right, that's my directory, and up it pops. Now, what's great is that once this comes up, help, training, and you can look at, what is TCAD and just read through everything, right? You just can read through gently of what it does. They're a little bit trying to sell the tool, so you don't need to read everything just to get an idea. But here's, training on Centaurus Workbench, right? I think you really should read the getting started. You don't have to do it, but just read what's going on, like opening up a project, running, selecting nodes. This one's probably just to read through it. All right. But you don't need to create a project build, all that, because I provide them for you. Not only that, but here are the manuals. All automatic. Now, I have a solar cell example for you, but you have all these examples, right? We have sensors, power, nanowire memory. Let's look at getting started, right? There's even a Centaurus Workbench example file, simple MOS, right? And I wouldn't run this one right away because it actually simulates the processing steps, which is more the MADI 262, right? They have Centaurus Device Editor, they have FinFETs, they have CMOS, anything you would, almost your heart would desire. Templates and things like variability. So really, if you were interested in just looking at one of these, all you have to do is click on it. I'm not quite sure what that is, so I'm just going to double click on it, and you can see that it's got some variables like its domain, PMOS, stretch, things like that. If I right click on it, I can edit the commands, and it looks like there's a tool where it reads in some data so things can be scaled. This will take some time to run, so I'm not going to do it for this video. But I believe it takes GDS mass data and runs it. Let's see, MOSFET 3D. Is that it? I don't know. That seems simple. So in order to create that into an area where it can be run, I am going to save it as a clean project in EE21, and I'm just going to call it MOS 3D. All right, now I can run it. Project operations run. You can set it to priority. Should run faster. And you can double click on that node and see it doing its thing. And it's not a simple structure, so it's setting the mesh and creating the structure. So when it's yellow like that, that means it's done. And if I double click on it, N1 mesh TDR, and just double click on that, I should see a 3D MOSFET, which I do. There you go. That's it for this video.